Students, in this class we will discuss some concepts about resistance and resistivity. This topic is applicable for both class 10 and 12, whatever the boards you follow. To calculate resistance, there are some formulas. Rs is equal to R1 plus R2 plus R3, that is for effective resistance in series. For parallel, it is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, that is for effective resistance in parallel. R dash is equal to N square R, that is for a wire is stretched, pulled and extended, stretched. For that, what is a new resistance? That is the formula. The next one is R dash is equal to R by N square, that is when a wire is cut and connected parallel. Effective resistance is R dash equal to R by N square. R equal to rho into L by A. R is resistance, rho is resistivity, L is length of the conductor, A is cross sectional area. And RT equal to R naught into 1 plus alpha into delta T, that is how resistance changes with respect to temperature. RT is resistance at high temperature, R naught is resistance at low temperature, alpha is a constant, and delta T. Delta T is a change in temperature. Now let us discuss some examples. The first one is imagine there are three resistors, 2 ohm, 4 ohm, 6 ohm are connected in series like this. Then effective resistance in series is Rs is equal to R1 plus R2 plus R3. Therefore, it is 2 plus 4 plus 6, which is 12 ohm. And the resistors are connected in series, just we have to add. Look at the next case, that is where imagine the resistors 2 ohm, 4 ohm, 6 ohm are connected in parallel. Then effective resistance formula is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Therefore, it is 1 by 2 plus 1 by 4 plus 1 by 6. Then you get 11 by 12. So effective resistance Rp is equal to 12 by 11 ohm, which is almost 1. So here what we understand that when the given resistors are connected in series, we are getting effective resistance higher value, more value. In case when the given resistors are connected in parallel, we are getting less value. Okay, that logic also we should understand. There is an example for another formulas where R dash equal to N square R. R is the old resistance, R dash is the new resistance, N is how many times the wire is stretched. Here you just imagine there is a wire whose length is L and resistance is 10 ohm. Imagine it is stretched for twice. So the length becomes 2L now. What is the new resistance R dash? That is a question. So R dash equal to N square R. How many times it is stretched? 2 times. Therefore it is 2 square into R. 2 square is 4. Therefore now the new resistance will become 4 times of the old resistance. Therefore 4 into 10, 40 ohm. In case if the wire is stretched for 3 times the original length, then the N value we should take it as a 3. In that case, R dash will be equal to 3 square times of R, which is 9 times of R. The first case is for when a wire is stretched. Okay, you can just compare with when we make chapati or puri, the wheat flour dough. Imagine it is in the shape of cylinder. And if you just give some pressure on that and roll it, what happens? The length of the dough increases, correct? Length extends on either side, but total volume is the same. So when the length increases, what happens? As volume remains the same, cross-sectional area decreases, correct? Thickness decreases, correct? Okay, so volume remains the same. So if you apply that V1 equal to V2, you will get this. So R dash equal to N square R. The next one is here you just imagine a wire of length L whose resistance is R, take it as 10 ohm, is cut into 2 equal parts, and then connected parallel. Then what is the new resistance? R dash equal to R by N square. What is the new resistance? That is 10 ohm. N value is 2 because it is cut into 2 equal parts and connected parallel. Therefore N value is 2. So therefore it is 4. 10 by 4 is 2.5. So the new resistance is 2.5 ohm. In case the wire is cut into three equal parts, and connected parallel like this, then the new resistance R dash will be equal to 10 by 9. 10 by 9, because now the n is 3, correct? Now n is equal to 3 in this case. Therefore n square, 3 square is 9, therefore 10 by 9. It's almost 1 ohm. So this is example for when a wire is stretched and elongated and extended, and this the right side, this is for when a wire is cut and connected parallel. And there is a formula for resistance that R equal to rho into L by A. R stands for resistance, its unit is ohm, and rho is resistivity, its unit is ohm meter. L is length of the wire, its unit is meter. A is cross sectional area, its unit is meter square. R equal to rho into L by A, ohm meter square by meter, then we get ohm meter. So ohm meter is a unit for resistivity. Reciprocal of resistivity is conductivity. Okay, reciprocal of resistivity is so 1 by rho is conductivity. 1 by rho is conductivity. R is directly proportional to length. Resistance is directly proportional to length of the conductor. Therefore, if length increases, resistance is going to increase. If length decreases, resistance is going to decrease. Resistance is inversely proportional to cross-sectional area. So, if cross-sectional area, that is thickness of the conductor, increases, resistance will decrease. If the cross-sectional area decreases, resistance will increase, because resistance is inversely proportional to cross-sectional area. Generally, any wire is treated in the shape of cylinder. Therefore, cross-sectional area will be pi r square. Sometimes there are problems given that cross-sectional area to be taken as a square or rectangle. Based on the question, we have to choose the formula. Now look at this question. This question is taken from State Board book, Tamil Nadu State Board book, page number 118. This is question number 2. The question says that a wire of length L, they did not mention how much length is that. It has a resistance of 2 ohm per meter. It is bent to form a circle of radius 1 meter. What is the effective resistance between the two ends A and B? That is the question. The formula is R equal to rho into L by A. Okay, resistance is directly proportional to resistivity, but resistivity, because the same material is bent to form a circle. Therefore, rho is going to be constant. Same wire is bent to form a circle. Therefore, cross-sectional area is also constant. So, resistance is directly proportional to length here. Resistance is directly. So, what we are getting here? Resistance is directly proportional to length here, and this wire is bent to form a circle. When it is formed to form a circle, circumference of the circle is 2 pi r. Circumference of the circle is length, total length is 2 pi r. Circumference of the circle is 2 pi r. And then r is a radius, which is 1 meter, and this wire has 2 ohm resistance for 1 meter. That is the question. Therefore, total resistance of the circular wire will be equal to 2 pi into 2, so which is equal to 4 pi ohm. Total resistance will be 4 pi ohm. Okay, and then we are asked to find out the effective resistance between A and B. So we have to divide this equally. Therefore, this portion will have 2 pi ohm resistance, and this portion will have 2 pi ohm resistance. Then effective resistance is, because they are parallel now, therefore 1 by Rp equal to 1 by R1 plus 1 by R2. So it is 1 by 2 pi plus 1 by 2 pi. So 2 times of 1 by 2 pi, therefore 2 gets cancelled, you get 1 by pi. So effective resistance is reciprocal of that, therefore it is pi ohm. This is the answer for the question. And there is another question from page number 6, which is 118 from Tamil Nadu State Board book. The question says that there is a wire A whose resistance is R sub x A, and then there is another wire B whose length is equal to the length of A wire. Resistance of A is equal to 3 times of resistance of B. Length of wire B is equal to length of wire A. What is the ratio between radius of A to radius of B? That is the question. R is equal to rho into L by A. R is equal to rho into L by A. then resistance of A will be equal to rho suffix A L suffix A by A suffix A. Resistance of B will be equal to rho suffix B L suffix B by A suffix B. And it's a cross sectional, it's a circular wire. It is given the question that the cross sectional area of the wire is circle. It is given in the question. Then we take pi r square, because cross sectional area of a circle is pi r square. So resistance of A equal to rho suffix A L suffix A. Instead of A suffix A we substitute pi r square, and similarly for wire B we substitute this. Also in the question it is given that resistance of A is equal to 3 times of resistance of B. So we shall write that resistance of B equal to 1 by 3 times of resistance of A. That is substituted here. Resistance of B is equal to 1/3 of resistance of A. That's what substituted here. Then if you equate these two and cancel, you get R suffix A square by R suffix B square equal to 1 by 3. Same material, therefore resistivity is getting cancelled. In the question it is mentioned that length of the two wires are same, therefore it is getting cancelled. Pi is also getting cancelled. Then you get R suffix A square by R suffix B square is equal to 1 by 3. Then R suffix A by R suffix B will be 1 by root 3, taking square root on both sides. Okay. And these questions are also taken from State Board book, page number 119, question number 10. You see that a 9-volt battery is connected to 3 resistors which are in series like this. This is 3 ohm, this is 2.5 ohm, this is unknown resistor. We have to find out its value. All the 3 resistors are in series, therefore R equal to 3 plus 2.5 plus P, therefore 5.5 plus P. Apply Ohm's law, V is equal to I into R, then R equal to V by I. Current value is given as 1 ohm in the question. Then you write that 5.5 plus P equal to 9. This is resistance, this is voltage. Current is 1. Then P equal to 9 minus 5.5, which is 3.5 ohm. Therefore, this resistance value must be equal to 3.5 ohm. So we are just finding the effective resistance in series and then apply Ohm's law. Ohm's law is V is equal to I into R. The another problem, that is question number 11, whereas 3 resistors are connected in parallel, all 3 resistors have same values as 15 ohm, 15 ohm, 15 ohm. They are connected to a 5-volt battery. They are asking what is the current drawn from the battery. Just we have to apply the formula effective resistance in parallel and then Ohm's law. 1 by Rp equal to 1 by 15 plus 1 by 15 plus 1 by 15, which is equal to 3 times of 1 by 15, that is 1 by 5. Therefore effective resistance is 5 ohm. We have to take reciprocal. So effective resistance is 5 ohm. Apply Ohm's law, V equal to I into R. I equal to V divided by R, then 5 by 5, which is equal to 1 ampere. Then current is 1 ampere. The current drawn from the battery is 1 ampere. Okay, and then imagine the current drawn is 1 ampere, correct? And then this is the junction where this is the point where all the resistors meet, correct? Okay, therefore and another thing is all resistors are same, therefore current will be equally divided. Applying Kirchhoff's first rule. Kirchhoff's first rule is that algebraic sum of current meeting at a junction is 0, correct? So if you apply that so 1 by 3 ampere of current will flow here, 1 by 3 ampere of current will flow here, 1 by 3 ampere of current will flow here. Current will be equally divided because the resistance values are same. And then this is about temperature dependence of resistivity. This is taken from NCERT book. NCERT book, page number 90. This is in NCERT book. NCERT book, class 12. This is in page number 90. Temperature dependence of resistivity. Look at the first graph. Resistivity. Okay, resistivity. Unit for resistivity is ohm meter. Correct. Unit of resistivity is ohm meter. Ohm meter. Temperature in Kelvin. Temperature in Kelvin. Temperature in Kelvin. First graph says that you look at this, that as temperature increases, resistivity increases. Okay, this is for metals, iron, copper. Okay, this is for metals. So if you find slope here, it is going to be positive. Therefore, alpha value is positive. Alpha value is positive. Okay. Alpha is positive, and here alpha is this, for this also alpha is positive. If you find slope, it's going to be positive. Here if you find slope, it's going to be negative. Therefore, alpha value is negative. Alpha, that is r sub x t equal to r naught into 1 plus alpha into delta t. Alpha into delta t. Okay. And the unit for alpha is per degree Celsius. Unit for alpha is per degree, so it is constant. And then what we understand from the graph is that even at zero value here, this is taken in Kelvin, therefore this is 0 Kelvin. We know that 0 degree Celsius equal to 273 Kelvin, correct? Then 0 Kelvin will be equal to minus 273 degrees Celsius. So even at minus 273 degrees Celsius, metals resistivity is not 0, therefore resistance is not 0. Even for alloys also the same, nichrome example. Here also, even at 0 Kelvin, the resistivity is not 0, therefore resistance is not 0. Whereas for semiconductors, when temperature increases, resistivity decreases. Okay, you can say that here resistivity increases. For the first case, you could see that resistivity increases, therefore conductivity decreases. For alloys, as temperature increases, resistivity increases, therefore conductivity decreases. For semiconductors, resistivity decreases, therefore conductivity increases. So what we learned from today's class is that some basic ideas about resistance and resistivity. Resistor in series formula, resistor in parallel. This is when a wire is stretched and extended. This is when a wire is fourth formula is when a wire is cut and connected in parallel. This is resistance R equal to rho into L by A. This is temperature dependence of resistance. And then some examples for resistor in series and parallel we discuss. This is when a wire is stretched and extended. The second one is for a wire is cut and connected in parallel. This is R equal to rho into L by A. And this is when a wire is made into form a circle, effective resistance across the ends A and B. And this is when a wire is here we are comparing the radius of the wires. Okay, when they have equal when they have equal length and the resistance is different, R sub x A, resistance of wire A is 3 times of resistance of B. And here based on we apply resistor in series and resistor in parallel formula, and then we are applying Ohm's law, and this is temperature dependence of resistivity. Okay, I hope these topics are useful to you. We'll continue in the next class. Thank you.